Welcome to section 4.5, Correlation and Causation. Today's objectives are to determine whether a data set or situation shows correlation or if it shows causation. Today we're looking at correlation versus causation. Yesterday we talked about correlation, and it just shows the relationship between two variables even when the variables are not related. It's just a set of data that we can plot. And then we can see that there's a correlation between two different items. Causation is when a change in one quantity causes a change in the second quantity. For example, a change in the amount of songs you download would change the amount of money you pay if you're paying per song. More songs, more money. The big key with this is correlation does not prove causation. Just because two things are correlated does not mean one of them causes the other. So you have correlation and causation, and we're going to discover this by graphing. And here it says the number of dogs and cats adopted at the Humane Society. And it shows your months, the number of dogs, and the number of cats that were adopted. And for step number 1, it says to make a scatter plot. So when we make the scatter plot, we want to look at what our low values are, and we want to look at what our high values are so we can make a scale, so we can fit our graph. One of those things you should recall is that since number of dogs is in the upper bar of our graph here, of our chart, that it is our independent. It will be on the x-axis. This is going to be number of dogs down on the bottom. So number of dogs. And on the vertical will be a number of cats. All right. So we need to look at how we're going to do our scale, and we look at dogs. We go from 39 as our low, and our high is 90. So we need to have a scale that can fit from between 39 and 90. I can just go by tens on the bottom if we want, because I can fit all the way to 100 on the bottom, and that is what I will do. We're just going to go by tens, and this goes all the way to 100. I'm just going to put a few on here so we can have something to work with. For our vertical for number of cats, we start at 53 and we go to 124. So 53 is my low, 124 is my high. This one, to fit them all, I am going to go by tens also, but I'm going to start my graph. I'm going to put a break in, and I'm going to start at 40. So my first spot here is 40. And then we're going to go up to 130 at the top. So this is 60. This is 80. Here's 100. Gives you an idea where we're working from. And then I'm going to go through and I'm going to plot my points. And so 90 goes to 124. So this goes way up to here. 54 goes to 72. So we're right around in here. When we do these scatter plots, it isn't estimating for the points. 62 goes to 95, which is right around in here somewhere. 39 goes to 53. So 39 goes to right around here. And 85 goes to 121. So we'll be right above the 120 line. Somewhere in there. That is my scatter plot. We have a table, we have our points. What type of correlation is shown? Well, when we go from left to right, we are going uphill. We could draw a trend line in here. I'm just going to put a very basic one here. That'd be a trend line we could put in here, and this is positive. If we wrote the equation of the line, it would have a positive slope. And does it show causation? Do the number of dogs that are adopted cause the number of cats to be adopted to go up? Well, in this case, there is no causation. Number of dogs does not influence how many cats. So we need to say why. Does this show causation? No, it does not. The number of dogs adopted does not cause the number of cats adopted to go up. People that usually adopt dogs are not going to adopt a cat also at the same time. They're just related in some other way, and most likely what it is that more people are going to the Humane Society during these months for whatever reason, and so if there's more people going to the Humane Society, they're going to adopt more animals. But the number of dogs adopted does not cause the number of cats to be adopted to go up. So there is no causation. We do another one of these where we do the correlation and causation by graphing. Again, the first step is to make a scatter plot. And again, we need to figure out what we're going to do for scales. We need to make sure we label our graphs. So that's one of the first things I'm going to do is label so I don't forget. And since our first bar here is hours worked, that is my horizontal. And the pay is the vertical. When we look at hours worked, we have a low of 17 and we have a high of 51. So we need to make sure we have a scale that's going to fit from 17 to 51. I am just going to go by tens. So 10, 20, 30, and 50. I can't go by fives, it wouldn't fit. So I'm just going to go by tens on that one. For our pay earned, our lowest pay is 149. And our highest pay is 448. So we need to make sure we start at least below 149.60 so we can fit it on our graph. So what I'm going to do is I'm going to put a break here. I'm going to make my first line 100. And I'm going to use a scale of 40. And so 140 goes to 180 goes to 220s up here. And then this is 260, 300 is right here. And then we go to 380. And our last one up on top here is 460. Okay. Then I'm going to plot my points. 17 goes to 149.60, so a little bit more than halfway across between 10 and the 20 mark would be going up to 149. Again, these are estimates when we do these points. 51 goes up to 448, so it's going way up here to right in this area. 49 goes to 431, so it's also just over. 42.5 is going to 374, so just under the 380 line. 29.5 is going to 259. 29.5. It's going to be right below, just hair below the line, so right around there. And 31 goes to 272.80. This is going to be right in, let's see, that's 260, 272 would be up in here. These points are really close. But we have a table so we know where the points are, even though we're eyeballing them when we put them on our chart. Make sure your points are close. Then it asks us what type of correlation we have. And again, we have a positive correlation. If I draw a line of fit, it will have a slope that is positive. And then it says in this one, does this show causation? Do the number of hours you work cause your pay to go up? And if you look at this, just thinking about it, yes, it does. In this situation, it does. The amount of hours, and you have to explain this. So the amount of hours worked causes pay to go up. For most people, this is what happens. If you have an hourly wage, the more you work, the more you get paid. For us that work with salary pay, this chart would actually not be applicable because I just get paid the same amount no matter how many hours I work because I'm a salaried employee. But this one does have causation because the hours worked does cause the pay to go up, which makes sense. All right, lastly, it says determine whether each situation illustrates correlation but not causation, or if it illustrates causation, and explain your answer. So the number of chocolate chip cookies you bake and the number of chocolate chips you use. Is this correlation without causation, or is it causation? This one is causation. When you're making cookies, if you're following a recipe, and that's how I'm going to explain this, if following a recipe, the number of cookies baked requires more chocolate chips. The second one we have is the pounds of sweet potatoes and pounds of spinach a garden produces each year. Is there correlation but not causation, or does the number of sweet potatoes or pounds of sweet potatoes cause the pounds of spinach to change? This is correlation. There is no causation. Just because I have more sweet potatoes does not mean I'm going to grow more spinach. So with this one, there's something else probably causing the difference. Maybe there's been more rain, maybe it's been sunnier, maybe the growing season was longer, but the sweet potatoes, the number of pounds of sweet potatoes does not cause the pounds of spinach to go up. There has to be some other cause. These are just correlated. There is no causation. All right, that is all for section 4.5. Today we're looking at correlation and causation. The biggest key is to realize that correlation does not mean there is causation. Make sure, again, when you're doing your scatter plots, you show me a scale, you label your graphs. Thank you for watching, and have a nice day.